In this video, we will graph parabolas and talk about some important properties of them. So the first page, I have a parabola in a vertex form. Y equals x plus 3 squared, and then I have minus 4 outside. So we just talked about transformation of function. This graph will be shifted down 4 units, right, because of that minus 4 outside. And there's that plus 3 inside. Because of that adding 3, this graph will be shifted left 3 units. So I can graph this. I can go down 4 and left 3, and I know my vertex is going to be right here. Okay? We already know how to find the vertex. Find the coordinate of the vertex. We went left 3, so negative 3 is the x-coordinate. And the y-coordinate is negative 4 because we went down 4. So using what we know about the transformation of functions, we can easily identify the vertex if it is written in this format. And this form is called, I called it vertex form, but some textbooks call it standard form or general form. But I always call it vertex form. Why do you think? Because it's so easy to tell the vertex. Because I'll tell you what, I want you to write this down. Can you write down what H stands for? H stands for the x-coordinate of the vertex. I want you to write that down. That's going to be very important later. And do write down that also K is equal to the y-coordinate of the vertex. So if you have an equation in that form, let me go ahead and make something up real quick. If you have an equation that looks like y equals 3 times x minus 3 squared plus 7, we should be able to just look at this and pick out the vertex. Okay, look. The vertex is going to be h comma, where h is 3. H is always a number being subtracted. Okay, so the x-coordinate is 3. And the y-coordinate, the k value is 7. So the vertex is going to be just 3, 7. Maybe another one. What if you have an equation that looks like y equals negative x plus 7 squared minus 3? What's going to be the vertex? Remember, x-coordinate is the h value, but h value is what's being subtracted. So think about it. If you are adding 7 inside, which direction are you moving to? Adding 7? That's going to shift the graph 7 to the left, right? So the x-coordinate will be negative 7. And the y-coordinate, because we shifted down 3, the y-coordinate will be negative 3. So just 2 quick examples, but we should be able to just look at an equation in vertex form. And based on what the h is and what the k is, we should be able to just pick out the vertex using the transformation rule, right? So that's why I like to call that a vertex form. I don't know why some books call it general or standard form. I can't remember, but I'll just call it vertex form, okay? All right, does this parabola, the one in the example, open up or open downward? You know the answer to this question. A is positive. I'll go ahead and say A is equal to 1, and this A is positive. Because A is positive, this parabola opens upward. Because A is positive. If leading coefficient is negative, if A is negative, it's going to open downward. All right, now this may be a new word in this section, axis of symmetry. All right, axis of symmetry, you know a parabola is perfectly symmetric. By what line? By the axis of symmetry. So what I'm going to do is I'm going to go ahead and sketch that axis of symmetry with a dotted line. I will go ahead and draw a dotted line straight through the vertex. You can't really see it, right? Hold on a second. Let me go ahead and use a highlighter or something. All right, I'm going to go ahead and draw a straight dotted line that is going through the vertex. Okay, that line is called the axis of symmetry. So here's the axis of symmetry. And the equation for that line is x equals, what's the number? Negative 3. Okay? Remember, axis of symmetry is always going to be the same as the x-coordinate of the vertex because axis of symmetry is sitting on the vertex. So do right, and remember they said equation, so you're going to need to draw an equal sign. Say x equals -3. Okay, so that is how you find the axis of symmetry. If someone says y equals -3, that is wrong. If someone says simply -3, that is wrong, because that's not an equation. So make sure you say axis of symmetry is always x equals. And how do I remember this? Take a look. If you look at this word, oh, whoopsie, sorry. It says x is. They really say x is. You see that, right? So axis of symmetry is always going to be the x coordinate of the vertex. I may write that down. Always the x coordinate of the vertex. Okay. Alrighty. Next question. Does the function have a minimum or maximum value? Now let's think about what we already discussed. This parabola opens which direction? Opens upward. So let me sketch a parabola that's opening upward. It looks like that, right? So the vertex, will that be the lowest point or will that be the highest point? This will be the lowest point. So if a parabola opens up, vertex is going to be called the minimum. If it opens downward, it's going to be the opposite, and we'll look at that on the next page. So because this parabola opens up, vertex is going to be the lowest point, right? And what do you think we're going to call this lowest point? We're going to call it the minimum. Does the function have a minimum or a maximum value? It has a minimum, and that minimum value is equal to -4. And if you're wondering, where did you get -4 from? That is a y-coordinate of the vertex. That is a y-coordinate of the vertex. And I think they're going to ask for it in section F. So we'll keep on going. We're gonna see that again in the other part. All right, next question. Where does the minimum or maximum value occur? It occurs at the vertex. It occurs where the vertex is. And vertex is at x equals -3. So if they're asking you a question, where does the minimum or maximum occur? By the way, this is not a maximum, right? This is a minimum. This will always happen exactly at where the vertex is. So that's why I say x equals -3. And F is asking, what is the function's minimum or maximum value? We know it has a minimum value, so let me just cross out the word maximum. And the lowest value, what is the lowest y value this graph will have? We know that is -4. And this is nothing more than the y coordinate of the vertex. All right, let's find the domain. Well, domain, if you think about it, what kind of numbers can you square? Can you square 5? Can you square -5? Can you square 0? Can you square fractions? You can square anything you like. So guess what? The domain is going to be from -infinity to positive infinity. Some functions have domain restriction. Like, for example, a fraction. You can't have 0 in the bottom of the fraction. Another example, square root function. You can't have negative number under square root. But for squaring function, for quadratic function, domain is always going to be all real numbers. So anytime you are asked what's the domain of a quadratic function, put -infinity to positive infinity. All right, the range is going to be a little different though. Range though, because the parabola has the lowest point and it's going to go up. We already said that the lowest point is going to be -4 and it's going to always go up. I'm sorry, not always. Some parabolas open downward. But for this parabola, the lowest point will be -4 and the rest of the parabola will go up, right? So what we know is that the range, the lowest value or the minimum value is -4. So I will put -4 with a bracket in front because we do have a value at -4. We do have a vertex down at -4. So it's a -4 all the way up to, you see the parabola goes up forever, right? Positive infinity. Now range of quadratic functions can be a little bit more confusing, but it has to do with the minimum or the maximum value. And it's always have to do with the y coordinate of your vertex. Okay? I usually skip this until I graph it. I like to see a picture before I write it down, so I can go ahead and graph it later and come back and check if this range is correct. Okay, let's go find the x-intercept and y-intercept. Write notes that y-intercept is when x is equal to 0. Okay, if you want to find y-intercept, plug in x equals 0. Why? Because to be on the y-axis, you should have an x value of 0. Okay, because if x value is anything other than 0, you're going to go 1 to the right or 1 to the left or 2 to the right. But to be on the y-axis, x coordinate has to be 0. That's why we're going to plug in x equals 0. So what was the function? The function was x, I forgot guys, let's see. Was it x plus 3? It was x plus 3 squared minus 4. So if I want to find the y-intercept, I'm going to plug in x equals 0. 0 plus 3 squared minus 4, which is 3 squared minus 4. 9 minus 4 is 5. So y-intercept is at 5. If I want to write this in order pair, that will be 0, 5. Let me go ahead and plot this on the graph that we have. So 0, 5 is going to be the y-intercept. And since I'm recording this as a video, anytime if you think I'm going way too fast, go back and watch it again. Stop the video and watch it again. I just don't want to have like a 90-minute video for you guys to watch. So I'm going to try to kind of go over this quickly. So go plot 0, 5. And let me tell you what's beautiful about this axis of symmetry. It's called axis of symmetry. So what we know is that if I have a point that is 1, 2, 3 to the right of the axis of symmetry, I better have another point that is 1, 2, 3 to the left of that axis of symmetry. So I'm going to have another point right there. Okay, so guess what? Now I have 3 dots. I'm going to need 5 dots, so let me find 2 more dots to plot. All right, let's go down and find x-intercepts. Look, if you wanted y-intercept, you plugged in x equals 0. So guess what you're going to do if you want to find x-intercepts? You're going to plug in y equals 0. Okay, and if you plug in y equals 0, you'll get 0 equals x plus 3 squared minus 4. Let's solve this for x. I'm going to add 4 to both sides. 4 equals x plus 3 squared. Let me zoom in. To get rid of squaring, we're going to take square root of both sides. But if you take square root, because square rooting is even, you're going to have to put plus or minus in front of it. And square root of 4 is 2, so we have plus or minus 2 on the left side. If you take square root, squaring cancels out, leaving us with just x plus 3. Now we have 2 separate equations. I'm going to go ahead and write the first one. The positive 2 equals x plus 3, or negative 2 equals x plus 3. And I solve them separately. If I subtract 3 from both sides, the first x-intercept is negative 1. If I subtract 3 from both this equation, the other x-intercept is going to be at x equals negative 5. So I have 2 x-intercepts that I'm going to plot both. The first one is negative 1, 0. And the second one is negative 5, 0. Let's plot them. Negative 1, 0. And negative 5, 0. And what's beautiful about this is, do you notice? 2 to the right from the axis of symmetry, 2 to the left from the axis of symmetry. So these 2 dots are perfectly symmetric. Yay! Now I have 5 dots plotted. I'm going to go ahead and draw a beautiful parabola. And if you look at this, if you're finding the range of this, you want to talk about the range of it. How low does it go? The lowest point is negative 4, right? But I have a square bracket because we have a closed circle at that point. And the next question is, how high does this parabola go? Goes up forever. That's why the range is negative 4 to positive infinity. And I usually wait until I actually graph it instead of looking at the minimum to write the range. But that is how you can graph and find all these properties of a parabola if an equation is in vertex form. I'm going to continue and do the same type of problem, but this time this is in a standard form. It's a little different, where you have A, B, and C. All right, let's do this one together, and I will stop the video after this example. This time, my equation is in, I like to call this standard form. Some books call this general form. Doesn't matter, as long as you know this is about where you have y equals ax squared plus bx plus c. This is probably the one that you use most often in high schools. You use your quadratic formula, negative b plus or minus, stuff. So let's identify our a, b, and c. What's a? A is the leading coefficient. A is -1. What's b? B is a coefficient of the linear term, and that is 6. And c is -5. And signs matter, so we have to be very careful when we are writing these signs, because signs are important. All right, let's see. Well, here's why. Does the parabola open upward or downward? And that all depends on the sign of A, right? What do you think? A is negative. Therefore, this parabola opens downward. Downward. Because A is negative. Now, this is in a vertex form, so you should not say the vertex is -6, -5. That is not right. We cannot do that. This is not in vertex form. So I will have to give you a new formula today, and I want you to know that formula. This is called the vertex formula. And this vertex formula will be used when an equation is in standard form, or aka general form. So I'll just call it standard form. If it is in this form, ABC form, then the vertex will come like this. Before I do the equal sign, it's going to be x equals -b over 2a. Vertex formula will find us the x coordinate of the vertex. So let's plug in our b and a in here. All right, this formula doesn't use c. So plug in the b and a into this formula. That will be -6 divided by 2 times a is -1. And let's simplify this. -6 over -6. -6 divided by -2 is +3. So x coordinate is 3. How do you find the y coordinate? Well, if you know the x coordinate, you can find the y coordinate by just simply plugging in that x value into the function. So now let's find the y coordinate. Y equals -x squared plus 6x minus 5, right? So if you want the y when x is 3, you just plug in 3. And this is where I'm going to pick up my scientific calculator to type in that note, that work. -3 squared. Oh, what happened to my iPad? Just went away. All right, let me try to connect back. You guys see the iPad? I don't see the iPad. Oh, Jesus, what's happening? I apologize. I'm having some technical difficulty. All right, it came back. All right, I'm typing in to figure out, to find out the y coordinate. If I type that in, this is what I'm typing in. I got 4. So the y coordinate is 4. So that is what you're going to have to do if the equation is in this ABC format. So we're going to plot the vertex 3 to the right of 4. 3 to the right of 4. So this graph has been shifted 3 units to the right and up 4 units. All right, they're asking you for the axis of symmetry. Axis of symmetry is always on top of our vertex, right? So if I sketch it with the dotted line, that is the axis of symmetry. And the equation for that is axis, right? X is equal to the x coordinate of the vertex, 3. All right, does this function have a minimum or a maximum value? Well, we already decided that this function will open downward. So if you sketch something like that, a graph that's opening downward, and you plot that vertex, that is the highest point, isn't it? Because this is the highest point, we're going to call it the maximum. So if a graph is opening down, we're going to have the highest point as the vertex, and that will be the maximum of the function. All right, let's see. Where does the minimum or maximum? It doesn't have a minimum, it only has a maximum. So where does that maximum occur? Maximum occurs at the vertex, so tell them that x equals 3. And they're asking you, what is the function's maximum value? How high does it go? The highest point of this function will be the y value of the vertex, so say that equals 4. Okay? These two parts come straight from the vertex, right? We're almost done. Well, what about the domain of any quadratic function? You know that domain of a quadratic function is always going to be all real, negative infinity to positive infinity. Like I told you that for the range, I tried to graph it first because I want to see a picture. I want to see a picture before I tell how low does it go, how high does it go. But by just looking at this, how low do you think this is going to go? It's going to keep on pointing down, right? So the lowest point will be negative infinity, right? It's never going to get there, but I'm going to say negative infinity with a parenthesis in front of it. How high does it go? What is the highest point of this graph? And we just kind of said it above, right above. The maximum value is going to be 4. So I'm going to say the highest point is 4, but it will have a point at that point. So I'm going to go ahead and draw a bracket. And I will confirm this answer by looking at the graph when we are done. Let's go ahead and find the y-intercept. Y-intercept is when x is equal to 0. So I will plug in x equals 0 into the y function. So the function was y equals negative x squared plus 6x minus 5. Let's plug in 0 in here. Y equals negative 0 squared plus 6 times 0 minus 5. And if you evaluate that, you will get negative 5. So y-intercept is at 0, negative 5. Let's plot that. 0, 5 right here. Remember, I love to use that axis of symmetry to find the second point. This point is 1, 2, 3 to the left of the axis of symmetry. So let me go 3 to the right and plot another point on the other side of that axis of symmetry. So that now we have 2 points. Let's go ahead and find the x-intercept. X-intercept happens when y is equal to 0, when the whole function value is equal to 0. So how do we solve this? We're going to have to factor this. I'll first factor out the negative because the leading coefficient was negative. So everything will change its sign. What used to be positive 6x is now negative 6x. And what used to be negative 5 is now going to be positive 5. Let's go ahead and factor that trinomial. What times what gives you 5? 5 times 1 does. And if they're both negative, they will add up to negative 6. So if we solve these two factors, what does x minus 5 equals to 0? That's true when x is equal to 5. We found the first x coordinate of the x-intercept. So we will plot 5, 0 on the graph paper, okay? The second one, when does x minus 1 equal to 0? That's true when x is equal to 1. So we will plot 1, 0. We have two x-intercepts to plot, one at 1 and the other one at 5. So one at 1 and the other one at 5. And I'm happy because this first x-coordinate is 2 to the left of the axis of symmetry, and the other one is 2 to the right of it. So this is perfectly symmetrical. So I can go ahead and pick up my pen and draw or fit a beautiful parabola. And this is definitely opening downward. And if someone asks you what is the highest point of this graph, we can see that the highest point is at 4. So our range is correct. Okay, let's go down and do one more thing. Now this is a daily problem that I ask you to complete. It's asking you to find the quadratic function in the form of this vertex form. So let's go ahead and do it this way. We know what A is. Didn't we identify what A is already? Let's go up and find what A was. Didn't we say A is equal to negative 1? A is equal to negative 1. Write down what H is. H is equal to the x-coordinate of the vertex. Therefore, H is equal to 3. H is equal to 3. h is always equal to the x-coordinate of the vertex, so h is equal to 3. All right, what about k? K is equal to the y-coordinate of the vertex. So let's see what that is. K is equal to, where's the vertex? 4. So if you can find the vertex, putting an equation in the vertex form is super easy. All you need to use is a is -1, h is 3, and k is 4. So plug in those values into this position and you will have your equation. So let's do that. F of x equals a first. A is -1, open parenthesis, and do x minus h inside. X minus h is 3, close the parenthesis and square it, and then do plus k outside. K is 4, so let's do plus 4. That is how you write the equation in vertex form using the vertex, the x and y coordinate of the vertex, and the given a value that we had in the very beginning. Okay? All right, I will be back to do the other learning objectives soon, but this is a good video for the first 2 pages of section 2.1.